Okay, time for our last session. We have a panel that came out of a paper submission. The panel is going to be chaired by Leslie Daigle, who has been around at the IETF since 1995, so for a substantial amount of time. So she has seen all kinds of ups and downs and changes in the internet, and that's probably puts her into a perfect position to talk about internet health.
Thank you very much, Jörg. So yes, this panel came out of a paper that I had submitted for this workshop about the network operator measurements activity that I've been working on. You can find more information about that at www.techarc.org/NOMA, or more likely, talk to me afterwards. So we're not actually going to talk about that, although I will provide a bit of context from it. But instead, we've got panelists here who are very well positioned to talk about metrics and internet health. I will ask them later to give a more detailed introduction themselves. But first, I would like to thank John Brzezowski from Comcast, Victor Korsing from Oracle now, and Robert Kistelecki from RIPE NCC for agreeing to be on the panel. So, yeah, so the basic thesis behind the NOMA work is to get operators, network operators, to self-instrument, to take measurements from the edge of their networks towards some well-known, user-interesting resources in the center of the network, to get a sense of how well their network is working. Let's put it that way, really roughly. The measurements are not complex. Things like measuring the time for HTTP connects over v4 and v6. And the thesis is that maybe a metric like doing the ratio of v4 and v6, or the difference between v4 and v6 times, would give you some sense of which protocol is working best from the vantage point of where you're testing. And if you look at it over time, you can have some sense of whether v6 is getting better or worse or what. So that is an extraordinarily high-level thumbnail sketch of what I was talking about, just to sort of lay some groundwork for the background that I was coming from. So I did actually have a panel description. Instrumenting networks, measurements to track network and internet health. This panel will explore the challenges of establishing a measurement collection framework within an operational network, instrumenting it for the purpose of tracking the network state, as well as contributing to a picture of the overall internet state of health. Apart from narrowing down what internet health actually means, challenges include choosing measurements that are meaningful markers of user experience, carrying out measurements within the network without otherwise impacting the network's performance or perturbing any target resources at which measurement traffic is aimed. No DDoSing. And these and other challenges and insights will be discussed by the panelists, from operators to infrastructure operators and network architects. So that's the context of this panel. And at this point, I would like to turn to the panel and ask each person to give a brief introduction of themselves, their background, and their relationship to this particular topic.
Okay, going from left to right, apparently. So hi, I'm Robert. I have been with the RIPE NCC for 11 years now, coming from security background, network security in particular. And then I joined the NCC to do RPKI, which some of you might have heard of, protocol work and so on. And later on, joined the then forming science team, which is now the R&D team, and I'm managing the R&D team ever since then. So the involvement here is that the NCC has been very active in the measurements and active and passive measurements of the internet for some time now. Some of you know RIS, the routing information system that has been collecting BGP data from around 700 peers or so since 1999. TTM, the test traffic measurements. Oh, public data is available, so that's kind of goes without saying. The test traffic measurements, which were instrumented, rack-mounted boxes with GPS antennas mounted on roofs and so on, so they can do one-way delay measurements with high precision. That was also running for like 12 years or so. Now it has been superseded. So we've been in this space for some time now, and somewhere around 2008-ish, we came to realize that there is, if network operators, which is our primary concern because we try to serve the ISPs in this region, whenever they have questions about, I think there is something wrong with the internet, it's not me. I don't really know who causes the problem and if there is a problem, but I feel that something is going on. There is a disturbance in the force, or someone actually complains about it. How do I go about it? How can I figure out what the problem is, where the problem is, and who is to blame, or how, more importantly, how can we fix it? So the only way was to talk to your friends and say, I think you have a machine in Vienna, right? Can I start pinging from there? And then rally up those kind of people to support you. So the intuition was that we still need some kind of measurement network that people can play with, and it gives them enough eyes or vantage points all over the world so that they can debug these kind of problems. Now, the RIPE-NCC is trying to stay on the network level, so our primary concern is the health of the network and not necessarily the health of applications and various research type of weirdly shaped packets and so on. But those happen as well. So we are trying to stay on the ping traceroute, DNS, and so NTP level. We do have HTTP measurements as well, but they are not publicly available because of reasons that we can go into later if that's a topic. But our approach was to build basically a community-based network. So if someone is willing to extend the network, then we should let them and we should encourage them. But in return, they should get some benefits out of the network. And I'm assuming that most of you know what RIPE Atlas is about, that's basically what you get. If you run a probe, you can do measurements. There's this loose correlation between the two. And along this road, we saw that there is a huge need for easily accessible tools and visualizations that monitor the health, if you will, whatever that means. We can also talk about that. But people, at least our target audience, were people who didn't really want to spend the time on figuring out how to do a measurement and then how to interpret the results. What they want is, does it work or doesn't it? And if it doesn't, who do I talk to? And I have to say that's surprisingly difficult to achieve.
All right. So my name is Victor Coursing. I'll give you a bit of my background and then I'll share some opinions. Currently working, I'll go backwards, I guess at Oracle, as you mentioned. We just got acquired. Our company was Dyn. So we're very much on the cloud services side of the equation at this point. Prior to that, small stint at Cisco, and then before that, about 13 years in a service provider up in Canada. So doing wireless and cable operations and business operations. So I've seen the issue from multiple perspectives, and that includes seeing it from the content/service provider, cloud provider side of it. You're trying to offer what is an increasingly common phenomenon of a third-party network offering services into SP networks, and that dynamic of where the service issues lie. Seeing it from a vendor perspective is how to tool our equipment correctly so that SPs can leverage or turn on the right functions to be able to metric their network or take statistics out of it and figure out what's going on. And from the SP side of the house, which was, if I think back to the late 90s and early 2000s when we did this, a lot of the functions that we required to understand the health is our networks were quite segmented back then. We inherently had that. It was part and parcel of that vertical integration we had way back then. And what's happened is, as we've kind of made this more ubiquitous network and data centers, and things have become more common on a single fabric, what's the issue we have is we haven't replaced all of those functionalities with a common set of tools and metrics to be able to understand, how does our service now run now? How do we deal with an infrastructure that has many services on it? And how do we understand, I know you want to get to the applications later, but how are we going to understand, or what's the right type of data to get out of here to understand what the implications will be for the upstream applications? So that's kind of my interest area, spending a lot of time, in terms of architecture design and operating all these systems from these different perspectives. And I see it as an increasing challenge because I see that not only inside the SP, are their applications or their services moving to these common data centers, and how do they figure out what's actually happening within the network? Because we struggled with that. You know, if we go back even starting about 5-6 years ago, we struggled with how do we convert all of these, what used to be these inherent tools we got from the vendors, to what do we create to be able to understand that, and a lot of the things happening with the internet. And then from the service provider's perspective, I mean, the content provider perspective, or, you know, the upstream cloud provider's perspective, is how do we access tools, or how do we provide functionality cooperatively with the SP, so we understand the health, so we don't get this finger pointing, or we don't, you know, where does the problem lie? Is it in the access network? Is it in these increasingly complex backbone networks? Or is it in the interconnection layer between all the providers? Or is it inside the cloud provider's infrastructure? And how do we tool these to get meaning out of them in a common way, so we could, at the end of the day, fix problems and really understanding health and attributes of applications. So that's my first synopsis.
Thanks, Victor. My name is John Brzeziowski from Comcast. Been with the company for a long time, going on 12 years now. So you know, anybody who knows me here, the vast majority of what I've done over the past decade and change is I've led the company's efforts to adopt V6. So about, you know, probably the best way to describe this is the, you know, first few years at the company were a lot of, you know, thankless work to upgrade the infrastructure, ready infrastructure that actually had no visible benefits or movement from the public's point of view. Upgrading servers, operating systems, products, what have you. So about 6 years ago, is when we started to really launch things that were going to end up in our customers' homes. Around that same time, when we were getting ready to do that, you know, we talked to, got all the right approvals internally, and one of the kind of the requests, air quotes, was don't break anything. Got it. Don't break anything. Right. So that ended up kind of blossoming into what ended up being an opportunity for us to kind of measure ourselves. Right. Initially, it was from a binary point of view to make sure that we didn't break anything. Right. To follow our, the kind of the mandate from our leaders. Turns out over the years, you know, we ended up building extraordinary relationships with many other partners in the ecosystem, which we'll talk about here in a few minutes. But it's also really kind of taken us down a couple of paths, right? It's, you know, when we deployed V6 as part of kind of enabling it on our infrastructure, we did it in a way that we didn't just simply carry forward the things that were done before. We looked at different, you know, V6 is an opportunity to do things differently, better, you know, optimize. Right? So if there's things and baggage that was happening that was in place before, we wanted to like take that as an opportunity to perhaps not do that again from a V6 point of view. That in turn led to a series of interesting phases where we said, hey, well, let's just take this from not a binary approach to measuring, are we broken or not, to, hey, wait a minute, what's the difference between V4 and V6? Oh, and by the way, in many cases, V6 outperforms V4. What are those scenarios? What can we explore there? And then finally, I think the chapter that is about to be upon us, and maybe in some places it is upon us, is what happens when V4 starts to degrade, right? You can't go back and measure, right? You can't go back in time, right? So, you know, starting these measurements and letting them run for extended periods of time is critical, right? And at least having that foundational baseline data is essential. You just can never go back in time to re-get it, right? So T0, you can't go back to, right? So with that, you know, Leslie, I'll turn it over to you, but that's the fundamental premise around why I think, you know, I'm up here, right?
Great, thanks. So I sent you all some questions that we get to, and let me now start with one that wasn't among those questions. But just sort of to put a little bit of a finer point on it, at least two of you brought up the notion of, you know, doing measurements can help you see where there are actually problems in the network. I wonder if one or more of you would like to give a concrete example to the room of where simple measurements can let you see something that's fundamental and important in the state of the network.
I have two. One that was, it dates back to World V6 launch. Was that 2012, right? Yeah. And one that's happening right now, right? So when a good friend of mine, Paul Saab at Facebook, right? So I was visiting Paul in his office, and at the time, I guess it was Palo Alto, and he's like, hey, so it's a month before the event. He goes, hey, let's let's turn V6 on and Comcast network. I said, okay, let's
Just
do it.
hanging around saying, hey, yeah, why don't we turn on V6?
So
Cool.
let's refill the beer first and let's give it a go. Let's give it a go, right? So and I said, hold on a second. I said, let me plug in www.facebook.com into kind of like the system, right? We'll talk about what the system is later. And he turns it on. We go out, get a bite to eat, come back, and I said, dude, you might want to turn that off. So it turns out in that case, and this is exactly the kind of relationship that I'm describing that blossomed, that really helps the internet ecosystem get together and fix things that affect millions of people on the internet. Turns out, the V4 traffic was being served out of something relatively close to Chicago. And then Chicago, but V6 was being served someplace in like the northwest of the country. So I'm like, it's not horrible, it's not broken, but it's not, the best. So we turned it off, he went off and did some things. The day or two goes by, we turn it back on, looks good, right? So that was really more of like, is it broken or not, right? And then lately, we have a situation with a content owner and a CDN where I happen to be measuring, so these relationships have kind of continued to blossom. The CDN, the content owner is basically LinkedIn, right? And I get a bunch of requests from them that says, hey, what's it look like on your network? How's things going? Because we're getting some reports of some weird, issues, right? So you plug in, LinkedIn URL and then collect some data for a while. And what we're finding is that there are issues both on my side and on another third party side where it's potentially affecting kind of the customer experience. Again, not broken, but like again opportunities for optimization, right? And the measurements, Leslie, and if you want to get into this later, that'd be great. They're not sophisticated. It's basically a wrapper built around libcurl, right? That basically does DNS lookup, TCP connect, and download time. Very simple for V4, V6.
Which you have distributed through your network.
Yeah, that's correct. That's right. Not entirely, but enough.
Anybody else? Yeah, I'm going to switch microphones on you because I think this one's easier for you to pass.
Grab two examples. One will actually reiterate something that John just said, and then I'll jump into a second one from a different perspective. So to the same event, different network, IPv6 Day 2012. When we were ramping up to it, we saw a very similar issue. And on the DNS, to go into the details of what we found on our SP side network was that, one can argue this came down to design deltas. This will continue to be true between V4 and V6. The V6 network was built differently because it was supposed to be built better. Why do we have to go back to the V4 world? Let's not make this necessarily 100% congruent. And what we found was, traffic was just inherently routed differently. Policy points in the network, how we did BGP policy across the network, and how we advertise things, although it was supposed to be the same basic general Anycast DNS distributions of the network, wound up taking traffic to different data centers. And when we worked backwards through the problem and found out where the issues were, and by the way, we found the issues because it was painstakingly like trial and error. What's going on here? Why is this happening? It wasn't instrumented. We finally discovered, there was issues within the network in terms of how the config was done, and we found out was a lot of manual processes on the V6 side. It was quite new back then. So, that's just to reiterate one of the things that John said, that we found that. So it's more than one network had the same or similar kinds of issues. We ramped up there, and it was one of those, wow, this can actually happen. And we've had other examples. Another perspective is I find implementations are differed between vendors. I'm not going to give away any vendor equipment at this point. But one of the things we found more recently was we had an issue where V4 actually kind of sucked. And we didn't have a V6 problem with this specific traffic flow when we were figuring out, what's going on with our UDP traffic. It looks like it's being dropped on the floor, going into this data center, what's happening. Well, we realized, now this might be that maybe the V6 implementation of ALGs was broken, but it sure performed very differently between V4 and V6. So we got a totally fundamental different behavior between V4 and V6 in terms of how UDP traffic was being managed. And there was some asynchronous nature going on without going into the big details. Now, had we been able to instrument the network, we could have found this problem a lot sooner than, and by the way, SPs will buy the exact same equipment we were using in these specific instances. We could have found this problem a lot sooner and not waited for, incredible number of tickets, a lot of problems, a lot of issues, a lot of troubleshooting, a lot of man hours. And, I'd rather spend that, to be honest with you, doing actual network implementation work as opposed to just troubleshooting. So it took a long time to find this. So we're seeing just implementation issues are hard to find. So instrumenting things can help us find things. In this particular case, V4 actually sucked more than V6.
I am constantly surprised about how much value researchers can squeeze out from the same data set day to day. And it's just a thing that we are still using the tools that we've been using 40 years ago, literally. Ping, traceroute, DNS lookup. And the volume has changed a lot. And I think in terms of detecting problems with V4, with V6, which one's better, what has changed, having a significant amount of constant data inflow helps a lot. We are measuring something like 4,500 results a second. That's what we collect, so 400 million data points a day, which is more than enough to pinpoint problems when they occur. The trick is, one of the tricks is that it's nice to collect baseline there. So, referring back to previous examples, if you knew how the network behaved before the problem came, and now you measure how it is behaving, then you can compare and say, that's the problem right there. Once you have a problem and then you start to measure, it's a bit more difficult. But